What's up, guys? In this one, we're going to do a quick walkthrough of this cost function. So remember, we defined the cost function to be given, an amount y and the prices, of the three inputs. We define that to be the solution to this problem. So in order to figure out what that's going to be, we have to find our x1, x2, x3 star that solves this problem, and then plug them back in to see what the cost actually is. So there are a couple ways we can do this. The first way is we can try to use calculus, which this is not differentiable. Quite obviously, we cannot differentiate x1, x2, x3. But if you are stuck on using calculus, think of it this way. If the minimum is bigger than y, it means that x1 has to be bigger than y, x2 has to be bigger than y, and x3 has to be bigger than y. This is what must be true. So if you wanted to use the calculus, if you just love the Kuhn-Tucker conditions, you could do this. But you could also just use your intuition. So if you're trying to spend as little as possible subject to producing this much, you would not want to produce any more than you didn't have to. You would not want to spend any more that you didn't have to. And so what that means is if I'm trying to produce an amount y, I'm going to want to produce exactly that amount, because producing any more will increase my cost. So I know then that I'm going to produce exactly y. See, I changed this to be inequality because now we know that. That's going to be what has to be true at the optimum. But also, it doesn't make sense to use, say, 3, 2, and 2, because we're only going to get a value of 2 out. So we're going to want all of these to be equal to each other. So we know also x1 star is going to equal x2 star is going to equal x3 star. And so using that, you can put that in up here. So explicitly, that means we'll just use x1 star is going to be equal to y, x2 star is going to be equal to y, and x3 star is going to be equal to y. And so we can put that guy up here, and we get p1y plus p2y plus p3y. And that's the cost function here. Now, what if we considered a slightly more difficult example? If instead of this, we, for example, made this 2x1 and 3x3. So now we know that we're still going to be holding with equality because we're not going to want to produce any more than we don't have to. And we know now that at the optimum, we're going to choose still for those to be equal. Because if any of these terms are bigger, we're wasting that. We don't need to do that. We could save money. So now we have this is going to be equal to y. From up here. So then we have x1 star equals y over 2, x2 star equals y, x3 star equals y over 3. And you can take these and plug it into this cost up here, and that's how you would get your final cost function. So before you throw calculus at these, think a little bit more and see if you can figure out with your intuition what the solution is going to deal with. And that's a good place to start.